Hello, you guys. My name is Armand Smith. I'm going to be talking about command-based programming for the 2015 spring training. Uh, I'm from FRC Team 321. If you're an outsider, and in our FRC team, we tend to use command-based programming. So let's get right into it. So you may be asking, um, what is command-based programming? How is it different from what your team probably uses, which is most likely iterative programming? Um, and how can command-based programming help you out? So command-based programming is pretty much a coding style that allows you to code things in terms of like modules. So instead of like looking at the robot from a holistic view, as in like looking at it from like the surface, you want to like really dig deep into the robot. What does your robot actually do in terms of subsystems, which I'll get into in a little bit, and how can your robot be broken down into different parts or modules, as I like to call them. And what command-based programming allows you to do, which iterative tends to lack, is it allows you to do things simultaneously between different subsystems. So in 2014, Aerial Assist, we this stupid thing. We had to, for autonomous, we had to put in the ball into the low goal. We did it in the low goal, and we wanted to do, let's say, 3 balls within the time frame they gave you, which I believe was 15 seconds, which is like typical for FRC autonomous. Um, so for us, we needed to drive and actually shoot the ball out or eject the ball out at the same time. And a good way to do that, code-wise, a very easy way to do that is by using command-based programming from the beginning. It also helps you a lot in the long run with like group dynamics and making sure that all of your programmers are on task and focused on a certain module instead of the entire robot as a whole. So the different pros and cons of command-based programming. So with the pros, you can debug systems individually. So instead of like looking at your entire robot like in iterative to see like what problems are arising in your robot, um, you can actually just break it down into different subsystems, because now you have your subsystems grouped in such a way that you can remember, hey, this is our drivetrain. Let's go here to make sure that we're driving correctly instead of going to the manipulator to see if that's interfering with our drivetrain. You can also easily create autonomous codes on the fly using command groups, and I'll get into that later in the PowerPoint. It's a very easy way to organize your code, because Java is a object-oriented programming language, and it allows you to use your different classes and group them accordingly, so that you understand what's going on with your different subsystems and commands. And like I said earlier, it is very easily accessible for group projects. So let's say you had like 5 to 10 programmers. You can assign different programmers to a certain subsystem. So let's say I had one programmer on the drivetrain. One programmer was responsible for a manipulator, like our first manipulator. Let's say like the arm, and then we have another programmer working on our secondary manipulator. Let's say like the intake, or in 2014, or for us in 2015, Recycle Rush, we had a vertical elevator, and we also had a intake for the actual totes themselves. So yeah, you can break up your programmers that way. But of course, with every pro comes a con. Well, in this case, not too much, but command-based programming can be pretty intimidating for programmers looking at the project alone. So, just past experiences, because I've pretty much worked on command-based programming with near one to three people, and it is pretty intimidating. You have to keep a lot of information in your head at one time, and I'll go over like how you can try to like document your code in a much more conveyable way for your group mates. But it's not very beginner friendly either. So if you're not used to being able to code in object oriented programming settings, then you're not going to really find this great. You should probably move to iterative. But this is me specifically talking to the Robolancers here. We use command base because it is a lot easier for us. One, for documentation on GitHub, and two, just organizing your code and making sure that everybody knows what's going on. It's also easy for the programmer to know, hey, we have a problem with the manipulator. Let's actually go to the manipulator instead of going to the drivetrain files for whatever reason. So with commands and subsystems, I've been using those terms a lot, and I neglected to actually tell you what they mean. So a subsystem is just different subsets of your robot. So let's say if I really broke down our robot from 2015 into different subsystems, I would say, okay, we have the drivetrain, we have the vertical elevator, we have the intake, we have our pneumatic system, we have our sensor feedback, and I like to keep sensors as a completely different subsystem because some sensors tend to be used for different things. Like some sensors are just like free roaming sensors that can be used for two different purposes. So I try to keep them in their own separate category. And so for commands, commands are just what you want your subsystem to do. You give your subsystem a command, and it follows the set of instructions that you give it. So what should be in a subsystem? So for us, we try to keep our subsystems pretty simple and actually make sense above all else. So for drivetrain, we just try to have it include the motor controllers or the wheels, so your different Talons, Talon SRXs, CAN Talons, things like that. Your double solenoid for if you have a sonic shifter, or you can actually keep the double solenoid in the pneumatics subsystem if you so desire. But personally, I try to keep double solenoids where they belong in terms of like how they're being used instead of like what it actually is as an actuator. Um, so yeah, drivetrain, wheels, motor controllers, double solenoid if you have shifting, things like that. Things that have to do with your drivetrain and only your drivetrain. With your manipulator, you should have your actual actuators in term that being motors, motor controllers. Again, if you have like talons that are using for to move like a wheelbase intake or something of that sort, or if you have a double solenoid because you're using pistons for whatever reason. If you have any sensors on your manipulator, what are they used for? Things like that. All things that have to do with that manipulator should be in the manipulator. And like I said before, subsystems should above all else make sense. It should make sense to you. It should make sense to the people coding with you. It should make sense to your coach um, if they're ever interested. It should make sense to the judges if you ever like to talk about your code in the pits for whatever reason. And 10 years down the line, if you ever want to look back at your successes as a programmer and you want to look back, it should make sense to you then. So make sure, like anything else, you name variables appropriately, you name your subsystem appropriately, and you put things that actually have to do with the subsystem in your subsystem. So with commands, commands just like subsystems, and I forgot to say this, subsystems takes the form of classes in your code, and they will be called as objects in Java. This allows you to do things like reference the different variables inside using different modifiers, but we're not going to go into that too much. This presentation already assumes that you understand basic visibility modifiers and object-oriented programming in Java. So subsystems and commands both take the form of classes, and they are called as such. So with a command, using a subsystem, you give a command to a particular to do particular functions. So let's say I had a drivetrain and I wanted to drive forward. Um, Using the drivetrain, I'd say, okay, um, I have my joystick and I want to give a translation of like the joystick, you moving the joystick to translate as actually moving the robot. So I'd call my command move with joystick, and in the actual command, I'd say, okay, get the joystick um, axes and set the motors to the values proportional to the joystick. Um, but as a more general sense, commands have several different things that will always happen in the command. They always have a requires function, which actually tells what subsystem is being used. So in this case, for move with joystick, it would require the drivetrain itself. Um, and then there's an execute, which is like a loop. It actually executes the command, and then you also have a is finished, which just checks to see if, for any reason, the command has been finished. So if I had a let me think of a better example. If I had a manipulator and I had an encoder on the manipulator, um, and I wanted to move the manipulator arm to a certain position, once it gets to that certain position, it is the command is then finished and it won't run execute anymore. And I'll go into that in the next slide with the command flow. So when you start a command, it always waits for data from the driver station first to make sure that, one, you're connected to the driver station, and make sure that you're actually connected to the subsystem that you're trying um, uh, to set a command to. So just make sure that the like the drivetrain actually exists in code, things like that. Um, and then it actually executes the command at least once, and then it'll go to the if finished um, line of the code. So it just checks to see if it is finished, and if it's not finished, it'll continuously execute um, the command over and over again. And then once it is finished, you can also have what's called an end method, which just says, okay, if I have a if I have a going back to the other example, if I have a manipulator that wants to go to a certain position, and once it finished the command, I would set it to stop at the end of the command. So that's pretty much the general flow of how commands work. So with commands, it allows you to take in joystick inputs and sensor inputs to a completely new level. It allows you to easily integrate like different kinds of sensors and different kinds of inputs into your robot. And it also lets you know, like, when it's actually finished, so that um, you have much more control of your robot. So this image here is just saying what I said in the last slide is just you wait for the data from the driver station, and then you check to see if there is a command and that the subsystem is actually available. And another thing that I'll talk about that you should probably know is like you can actually interrupt commands by calling other commands. So if you can interrupt a command and you call the command, then it'll completely stop the command, and then it will go to the old command. So you actually can't do more than one command per subsystem at a time, but you can do multiple commands um, throughout the subsystem. So like if I had two different subsystems, the drivetrain and the manipulator, I can drive forward and use the manipulator at the same time. But clearly you can't, let's say, have a manipulator and try to move it to a set position while at the same time like doing some other obscure thing with the manipulator. It doesn't physically make sense and doesn't make sense in code either, so you shouldn't try to do that. Um, so another good thing with commands is that you can also schedule commands to happen over time or in sequence with other commands. So going back to that example, instead of trying to do two things at the same time with one command, you can actually set two things that happen in sequence with a command. So the next slide we'll talk about. Oh wait, I'm not there yet. So let's say I had an arm and I wanted to uh, pick up um, a toad from the 2015 Recycle Rush game, and then I wanted to immediately put it down. I would set my command for the manipulator to move the arm up, and then once it got to the position it needed to, it would say okay, stop, and then it would immediately go to the next command, which is putting it down, and that helps a lot in autonomous. And I'll go over that in the command groups um, slide. So command groups allow you to do what I call macroing. That's what they call it in like the gaming community, I guess. Macroing commands, which lets you string commands together to do certain tasks, like to do certain very complicated tasks. So it's very useful in autonomous, where you have to do more than one thing. So um, I said this before with in 2014 doing a three ball autonomous. You want to drive into the zone, and then you want to shoot one ball, shoot the second ball, shoot the third ball. So you're doing a few different things there if you really break it down. You're one moving into the zone while at the same time shooting, and you're also shooting three times in succession while knowing when you finish shooting, depending on your manipulator, and like making sure that all of your actuators are reset after each shooting iteration. Like let's say you had like a wheel intake, you had to like rev up your wheel intake in order to actually get the motion that you needed to shoot the ball out. Um, that would be a good place to use um, command groups. So yeah, it allows you to do allows you to do things in sequence or simultaneously with other commands. So like I said, driving and shooting at the same time. So some examples of command groups. Um, we have a an actuator here. This is a arm, and the idea is that you want to place soda. You want to prepare to grab the soda, and you also want to place a soda. So, in terms of placing a soda, you want to do three different things in sequence. You want to set the elevator set point to the table height. You want to set the wrist to pick up the actual soda, and then you want to open the claw. So you're doing three things in sequence instead of doing things at the same time. And then the second thing shows you with the prepare to grab how you can do things at the same time. So in this case, you're going to do all three things at the same time. Um, setting your wrist, setting the elevator, and opening the claw all at the same time. And then presumably you're going to close all three of them at the same time to actually pick up the soda. So, um, so yeah, a lot of my images I got from US First website, but that's not what I want to get into today. I want to really get into talking about how we use um, command base on our team. So I'm going to go to um, our repository, the Robolances repository, and actually show you some of the different ways we use command bases here. So here I have a bunch of folders. I have our commands folder, a subsystems folder, and then there's a bunch of other folders that are pretty irrelevant right now. We're mainly going to look at these two folders here. In subsystems, we have 7 different subsystems here. We have our camera class, which we never actually use. That would be used for gathering information via camera. We have our chain lift, which is a vertical elevator I was talking about for the 2015 Recycle Rush game. We have our drivetrain, which is, as you can assume, your chassis, your wheels, your motor controllers. We have a shifter, so we shift. well, actually, no, not on this robot. We have Mechanum, so it's a lot more complicated uh, than it should be. But if we had a shifter, we would shift there, things like that. We have our feedback, which is any other sensor that didn't fall into any of these categories. We have our feeder, which is how we obtain the toads from the landfill. We have our can grabber, which is a very odd element to this game where you actually steal the cans from the middle step. And then we have our pneumatics. Um, I don't want to go into drivetrain because that's very complicated. So I'll go into feeder and I'll just show you how, because this is a very simple thing here. In the feeder, we can see that it extends the subsystem class. Subsystem is something that's given to us by the WPI libraries, um, and that's just like a base class. That's how you use your commands, and I'll go into that later. Um, so here I did some unassigned variable stuff with speed controllers saying, hey, let's make left wheel and the right wheel because we have two wheels on our intake, and then I called them in the constructor feeder. Their talons, and then we also have the feeder solenoid, um, things like that. Notice how all of these are public, meaning that the command can actually access these things, and other classes can actually access these things. So um, any class that any class that ever wanted to do anything with the left wheel, the right wheel, or the feeder solenoid can do so, and that's how we actually get into joystick inputs with the operating interface, things like that. There's also this void here called init default command. That's how you initialize your default command. So if you have like a drivetrain and you wanted to have your default command be move with joystick, and it runs forever and it never turns off, you can just put that right here by calling set default command and then new command name. Um, yeah, and then this is just a void that says this is how you use a feeder. You input power, and then you set the wheels to their voltages. You set the motor controllers to their voltages. Um, yeah, I probably should go into drivetrain. Drivetrain is a lot more complicated. It uses a lot more classes and references than it should, which is why I said in the beginning that command base can be very daunting to newer programmers. You guys aren't going to be able to do things like this right off the bat. You guys aren't going to. You're probably not going to want to use things like PID, um, especially a custom PID that we use, Lancer PID, um, and do a lot with like calling references back and forth through commands and other classes. But what command base is really good for is autonomous. So I'll go into that right now. So with commands, we go into our commands folder. I'll go to autonomous and I'll show you how we um, how we did a few things. So like drive facing angle. I shouldn't do that. That also uses custom. A lot of these classes use custom things because we're so used to using command base that we sort of just take it for granted at this point. Um, Let me think of a very easy thing to do. Okay, chain to set point, right? So you have your chain to set point, um, and it requires the chain lift subsystem. Um, it also takes in um, the different type how you're going to actually use the chain lift. So are you going to um, is your value your next argument, is your value going to be a level, like a specific level of totes, because you could stack up to 6 totes, so you wanted to know how many totes you could they actually had on hand, or is it going to be like an absolute value, um, like is it going to be a very specific or odd set point that you want. So that's a that's just what those variables mean. And then you set them all in the constructor. We don't do anything on initialize, so we're not going to worry about that. But when it executes, what it does is because this is a object, and if you're already experienced in object-oriented programming, you would know that you would probably know this already. When you call a new object, it stays it exists until you destroy the object, pretty much. And commands are objects. So what happens is when you call execute, it's going to continuously run execute over and over and over again, but it'll never do initialize again. So we do what's called an on first pass type thing, um, where we like do a bunch of stuff with PID and do a lot of stuff in the background every time that this command is called, instead of saying, "Hey, when we have the command, as soon as the command is initialized, then we do what's in initialized." It's a lot more like uh, it's a lot more complicated than it sounds, or it's a lot less complicated than it sounds. But if you really have like experience programming, then you've probably seen problems like this arise several times in your programming career. But let's not get too hung up on that. This is just the basic structure of a command. It extends command. It has your execute, and it has it is finished. So for is finished, it actually just says, "Hey, is the chain lift um, at the set point that it's supposed to be in PID?" And if so, then you stop the chain lift, and then it resets the first pass thing that I was talking about before. Um, Now we can go into the actual robot. So, um, if you, so we've been talking about a robot in terms of modules and like different subsystems. But how do we talk about a robot as an overall um, as an overarching body, like actually encompassing all these subsystems? And this is where the robot class comes into play. So robot extends iterative robot. That's another um, thing that WPI has given us, and we're not really going to go into. This is where we're actually going to call all of our different objects. We're going to call them all here. So we're going to initialize all the subsystems. We're going to make sure that the drivetrain is drivetrain. Make sure that the chain lift is called the chain lift. Things like that. And then we have the operator interface, which just allows us to do joystick controls. Um, and then there's a bunch of other things that I have here as well. That has to do with like the smart dashboard, being able to actually view things on a heads-up display um, on your computer. Things like choosing your autonomous, things like that. That again, I'm not going to go into because that's a more advanced programming topic. Now, I just bombarded your brains with a lot of information, and you guys have no idea how you're going to get started, how you guys are actually going to be able to do the things that we do in command-based programming. How are you guys going to make sure that you know where all your methods are? How are you guys going to know um, what visibility your different variables are? How are you guys going to know um, what you can and can't do with your subsystems? And that's where a thing called UML comes into play. So UML is essentially a modeling language. It allows you to model code in a very organized way, and allows you to maybe print out your models or send them to your different peers and actually show them how your code works, not from a code perspective, but from an actual perspective that they can understand in terms of like a flowchart. So this is just like some UML diagram example. So like this is a class tree. If I can save this or can open is a completely different like language. This is probably CSS or something. I can't tell. Um, but this allows you to oh, it's JavaScript. This allows you to understand how your code actually works from the perspective of like a human being instead of as a as a programmer. So people who have never touched your project can understand how your um, how your program actually works and your thought process behind it all. So in this example, and this is me just looking at it from the outset, you have a person who actually uses this client page. This is a web transaction page. Who actually uses this client page, and then they go to the main page, and from the main page is a bunch of links. Um, you have your search results, and that allows you to go to um, your different cart items. So you can either add an item, delete an item, update your cart, verify an order, fulfill an order. Like these are your options that you can do, and then from there, they give you different information on your the type of currency, whether it be in U.S. dollars, um, the pounds, uh, any different kind of worldwide currency, the amount of the currency, the amount of items, shipping, tax, things like that, and then all of that gets input into an order form, and then that's where you're actually um, yeah, that's where your shopping cart comes into play. So like all that stuff stays in your shopping cart, and then you can submit your order. You verify your order, or you can actually do that from your shopping cart as well. You can after you submit your first item, you can either submit or just go straight to the verification, and then it'll show you, hey, you bought this item. Um, this is your receipt, things like that. Like this is me just looking at it from a very open view of it. Like I've never seen this diagram before, but this is how UML can actually help you to understand how how to code your robot. So if I had a UML for our robot, it would be it will be slightly messy, but it will pretty much say, hey, you have a robot. Your robot encompasses all these different subsystems. This is what your drivetrain does. Your drivetrain can move. It can move to certain positions, things like that. Um, and then you can also have the different commands that the drivetrain uses, whether it be driving in a straight line. We have mecanum, so it can drive left and right, things like that. Drive left and right for a certain period of time, and then you have your again you have your robot, you have your manipulator, and actually just going straight through all the different subsystems and how they all intertwine with each other, how they work with one another, what they do, and all the variables that other classes have access to. So I hope that gives you some insight on um, command-based programming and UML, um, and hopefully you can possibly take this to your FRC teams or try to continue the trend throughout our FRC team, 321 Robo-Lancers, if you guys are watching this. So yeah, thanks for watching, and if you guys have any questions, you can always email me at smithark97@gmail.com, and I'll try to answer your questions at any time. The email will be in the description to this video. Thank you guys.